Welcome to EDU World Space.
In this problem, we have a converging lens behind which there is a diverging lens. The diverging lens has the focal length of 33.5 centimeters, but because it's diverging, we write it as a negative number. And the converging lens has a plus 20 centimeter focal length, and the distance between them is 14 centimeters. So we have an object at infinity, somewhere over here, and this distance is infinite. Infinite just means large enough. So for this problem, it would be about 10 meters would be good enough usually. Now, the light rays that are coming from this object from infinity will be coming in parallel. Obviously, because it's a converging lens, they will all go converge somewhere. Now, this convergence will happen 20 centimeters after the lens. So this distance is 20 centimeters. But obviously, the light before it converges and becomes the image hits the diverging lens. So what happens? This light which is coming in would have fallen here, which would have formed the image for the converging lens. Now, this light which would have formed an image over here acts like a virtual object for the diverging lens. So, this light which comes in gets diverged because of the diverging lens. So, what is the object distance? Obviously, it's 6 centimeters. The total distance is 20 centimeters minus 14 centimeters will be 6 centimeters. But obviously, because it's a virtual object, we write it as minus 6 centimeters. That's the convention. So now we'll use our simple lens maker formula on the diverging lens. 1 by image distance plus 1 by object distance is equal to 1 by f, which means 1 by image distance minus 1 by object. I'm sorry, it's plus 1 by object distance, but the object distance is negative, so that's minus 1 by 6 is equal to 1 by minus 33.5 centimeters, which means 1 by image distance is equal to 1 by 6 minus 1 by 33.5, which means SI is 6 into 33.5 divided by 27.5. That is it. This turns out to be 7.3 centimeters. Notice how it's a positive number. It means that the diverging lens is here. The light rays come converging. They would have converged somewhere, but they just get a little diverged, but they still converge somewhere a little far away. And that is it. Because this distance is positive, it means that the image lies somewhere over here. So beyond the diverging lens. And it lies 7.3 centimeters beyond it. So that's just 1.3 centimeters after the original virtual object.